So in the first part of chapter 1 here, we're going to look at some different things involving rectangular coordinates, which is going to encompass a couple different things. The first of which is just some different things with plotting points. So if you're familiar with the coordinate plane here with your x-axis and your y-axis, and I'm looking at this diagram over here on the right, just some different terminology here, things here first. So you have first the horizontal axis here, which we refer to as the x-axis. You have the vertical axis here, which we refer to as the y-axis. And then any point that falls not on either the x or y-axis, we say falls in the spaces between the x and y-axis, those fall in quadrants. So the top right corner here is quadrant 1. To the left of that here is quadrant 2. Down here on the bottom left is quadrant 3. And then finally you have quadrant 4 down here on the bottom right. The origin, sort of last term that we're going to look at here, the origin is the point 0, 0. That's the point where the x-axis and the y-axis intersect. That is, when you're graphing points using coordinates, that is always the starting spot with graphing any type of points there. So some other things just keep in mind with coordinates, and hopefully this is some review stuff here, but you have an x-coordinate and a y-coordinate. So when we're talking about points, every point has an x-coordinate and a y-coordinate. The x-coordinate represents the horizontal distance that a point moves from the y-axis, and the y-coordinate, that represents the vertical distance that a point moves from the x-axis. So just a key note here on the bottom, the notation x comma y denotes both a point in the plane and an open interval on a real number line. The context will tell you which meaning is intended, and we're going to get to some different things with solutions in a few weeks here, where we're going to use a similar type of notation that we use for the coordinates of a point to define the distance along a number line. So some more details sort of to follow about that in a few weeks. So the first example here, we're just talking about doing some point plotting. So I'm going to take each of these 5 points and I'm just going to put them all on the same graph here. So the first point, negative 1, 2. So keep in mind, I'm going to start at the origin and I'm going to go 1 to the left, since that's a negative 1, and then up 2. So that first point is going to be like right about here. Second point I have is 3, 4. So since the first coordinate's positive, I'm going to go to the right 3. So I got 1, 2, 3 there. And then the second coordinate is a positive 4, so that means I'm going to go from here, I'm going to go up 4. 1, 2, 3, 4 there. And that's where my second point's going to go, right about here. Then I have the point 0, 0. So 0 as a first coordinate means don't go left or right. 0 as a second coordinate means do not go up or down. That's just the origin, and that's the coordinates of the origin, 0, 0 there. Next point, 3, 0. So since the first point's positive, I'm going to go 3 to the right. And then once again, since that second coordinate's 0, that's telling me not to go up or down at all. So I have a point right there on the x-axis. And then finally, I have the point negative 2, 3. So since the first coordinate's negative, I'm going to go 2 to the left. And then since the second coordinate is also negative, that means I'm going to go down 3. So that point's going to be maybe right about here. So if you're talking about quadrants here, notice this point right here, this point's in quadrant 1, this point here is in quadrant 2, this point here is in quadrant 3. Notice I do not have any kind of points here in quadrant 4. What I would say about this point here is that that point is on the x-axis. So remember, quadrants only refer to points that are not on either the x or the y-axis there. So just some different things with kind of following up with some of the terminology things we talked about previously. So the next example is how to sketch a scatter plot. So the table here shows the number, and this is in millions, of subscribers to a cellular telecommunications company in the United States from the years 2001 to 2010, where T represents the year. And the question says just to sketch a scatter plot of the data. So I got my graph here. So I'm going to put the time, the years down here. I'm going to put T down here, and then up the side of this I'm going to have my values of N. So since this goes from 2001 to 2010, I'm just going to use the last digit of each of the years here on the graph. So I got 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, and 2010. And then for the values of n, this goes from 128.4 all the way up to 311. So I'm going to take, if you notice here, I have 10 lines going up the side here. So if I did this in, let's say, maybe in 50s, that should make it so I had enough room to include all these values here. So you don't have to scale this in 50s. You can scale this in pretty much anything you want, just as long as when you get to the top of your scale that the largest value that's in the table here, which is 311.0, as long as that value will fit when you get to the top number of your scale, you can pretty much scale this in anything you want. So tell you what, let's take this table here and let's maybe move it over to here so we can get a better picture of that. So here's the first point, 2001, 128.4. So here's 2001, 128.4 might be, I don't know, right about, get my pen up here, it might be right about here. Here's the second point, 2002 and 140. So here's 2. 140 might be right below the 150 there. Maybe something like that. Then I have the third point, 2003 and 158.7. Here's 2003. 158 might be like right above that 150 there. So there's another point. Then I have 2004 and 182.1. Here's 2004. 182.1 might be right below that 200 there, so it might be like right about here. Then I have 2005 and 207.9, so 2005, 207 might be right above the 200. So you get something like that there. Then I have 2006 and 233, so that might be just below the 250 there, maybe right about here. Then I have 2007 and 255.4, so that might be just above the 250, maybe right about here. Then I have 2008 and 270.3, which would be kind of in the middle between 250 and 300, maybe right about here. Then I have 2009 and 290, so that might be just below the 300, that might be right about here. And then finally I have 2010 and 311, that might be just above the 300s. I get something like that there. So that's essentially what you need to do in order to make a scatter plot. You have to scale your x-axis, you have to scale your y-axis, and then from there you just simply plot the points. So as far as sort of a cleaned up version of what this looks like in your calculator, I sort of have this here for you, just a bit of a more cleaned up version of what we did. But you can see here the scales for this pretty similar to what we did in the example here. The other thing you can do with your calculator in regards to scatter plots is your calculators can also make scatter plots. So to make a scatter plot in your calculator, what you want to do first is you want to push the Stat button here, and then you go to Edit, and I'm going to sort of clear some stuff out here so I have some room to put this in. So I'm going to work with my L1 and L2 columns here first. So similar to what I did with my graph here with my scales, when I did this version here, I just put the last digit of each year in for my x-axis, and I'm going to do the same thing with my calculator. I'm going to put, instead of putting all the whole years in, I'm just going to put the last digit there for each year in. So I'm going to have my numbers from basically from 1 through 10 here. And then when I go to do the L2 part of this, I'm going to put in these values here in the L2 column. So first I got 128.4. I'm going to kind of minimize this just so I can see the values better. So I got 128.4. I got 140.8. I got 158.7. I got 182.1. 207.9. 233.0. 255.4, 270.3, 290.9, and finally 311. So in order to make a scatter plot, there's a couple different things you have to do here. One is you have to put the table of values in the calculator. Next, you have to tell the calculator what kind of graph you want it to make with that table of values. And in order to do that, you push second and then y equals, and you go to where it says plot 1, so you can push 1 or just push enter there. And then if you notice this first graph here, this is the type that we're looking for, a scatter plot. So first make sure your plots are on, and then you want to use your down arrow key, go to where it says type, and we want to choose the scatter plot here. And then where you have your x and y values, notice we put our x values in L1 here, so I want to push second 1 for L1. And then for the y values, they're in the L2 column, so I want to push second 2 for L2. So that's the second thing you have to do to make a scatter plot. You have to tell the calculator what type of graph you want it to make. Then from here, the last thing I have to do is I have to set the window. So the easiest way to do that is just to push the zoom button, and if you notice at the bottom here it says zoom stat. So if I push 9 there, what it will do is the calculator will then just set the window for me. So there's the scatter plot of the data that we just did. So that's just something you can do in your calculator in a real quick and easy way there. So just kind of moving on to some other things involving points. So we're going to get into looking at some things with the distance formula. And the distance formula and where the distance formula comes from has a lot to do with the Pythagorean theorem. So if you recall the Pythagorean theorem, for a right triangle, we know that a squared plus b squared equals c squared, meaning that the square of the one leg of a triangle plus the square of another leg of a triangle is always equal to, their sum is always equal to the hypotenuse squared. So a lot of what we do with the distance formula, and this sort of walks you through a little bit of where the distance formula comes from in regards to the Pythagorean theorem here. So the distance formula, which is this right here, and I'm going to sort of show you this on the next slide. The distance formula is what you use in order to find the distance between 2 points on a graph. So we have here d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So the next example, it says find the distance between the points -2, 1, and 3, 4. So what I want to do first here is I want to take these 2 points just so I can visualize what this looks like. I want to put these 2 points on the graph over here. So I'm going to first graph -2, +1 is going to be here. And then the other point would be 3, 4. So here's 3, up 4 would be here. And what I'm essentially looking to find is what's the distance between these 2 points here. So where this kind of relates to Pythagorean theorem a little bit is if I took this line, or this segment, and I drew a right triangle out of it, I could do here a squared plus b squared equals c squared here. And that would tell me what the length of that segment was, or I could use the distance formula, which we're going to use here. So when I go to use the distance formula here, this is going to be the square root of x2, which would be 3 here. So this would be 3 minus x1, -2, squared, plus y2, which would be 4, minus y1, which would be 1, squared. So when I go to work this out, this would be 3 minus -2 is 5, and 5 squared would be 25, plus 4 minus 1 would be 3, and 3 squared would be 9. So when I go to work this out, this ends up being the square root of 34. And since the square root of 34 cannot be simplified, we're just going to leave that as the square root of 34. So that's the distance that you get between these 2 points right here. So just one last thing that we're going to look at in regards to the distance formula. In the question here it says, show that the points 2, 1, 4, 0, and 5, 7 are vertices of a right triangle. So let me once again start off by just plotting these points and connecting them just to see first if it even looks like a right triangle. So the first point here, 2, 1, I'm going to go 2 to the right, up 1, so I got a point there. Then I have 4, 0, which would be 4 to the right, and then stay on the x-axis, so that's going to be there. And then I have 5, 7, which would be all the way up here. So that would go here. So now when I go to connect these points, I have here, here, and here. So just based on the way this looks, it looks like this angle here might be the right angle. And here's C. And then I can label these as either A or B here. So what I want to do here is I want to find the lengths of all three of the sides here, and then maybe I could do Pythagorean theorem at the end to prove that a squared plus b squared equals c squared. So I got a couple different distance formulas that I want to do here, and what we'll do with this a little bit is we'll talk some calculator stuff with this. So if I first take the length of side A, let's say, which would be the point 2, 1, going all the way to the point 5, 7. So if I did here x2 minus x1 squared, this would be 5 minus 2 squared plus y2, which would be 7, minus y1, which would be 1 squared. So just to try to sort of expedite this a little bit, I'm going to pull my calculator up here, and I'm just going to go right to sort of putting all this in one shot here, just a little shortcut here. So I got here, first I have 5 minus 2 squared. So here I have 5 minus 2 in parentheses, and I'm going to square that, plus, then another parentheses, I have 7 minus 1 squared. And when I hit enter here, this is going to give me the square root of 6.78. So if we just squared that, this is going to end up being the square root of 45, let's call it for now. That's a little bit easier for us to work with here. So I'm going to call this the square root of 45. So square root of 45 can be simplified, but for the purposes of what we're looking at here, it's probably going to be easier for us to leave the square root of 45 as just the square root of 45 for now. So that's side A. Side B, I'm going to find by taking the length of the sides from this point here to this point here. So when I go to do the square root here, this is going to be, first when I do x2 minus x1, I have 4 minus 2 squared plus, then when I have y2 minus y1 squared, this would be 0 minus 1 squared. So once again, I'm going to use my calculator here. So first I have the square root of 4 minus 2 squared plus 0 minus 1 squared. So I got a new parentheses here. I got 0 minus 1 squared. And when I work that out, I get 2.236. If I square that, this just comes out to be roughly the square root of 5. So I'm going to just leave this as the square root of 5. And then finally I have side C, which basically connects the 2 points 4, 0 and 5, 7. So when I go to do the square root of that there, this is going to be first x2 minus x1, so this will be 5 minus 4 squared plus y2 minus y1, so this will be 7 minus 0 squared. So when I go to work this out, so first I have, and kind of clear this out here, I have the square root of parentheses 5 minus 4 squared plus parentheses 7 minus 0 squared, which we know obviously is 7. So this comes out to be roughly about 7.07. If I squared that, that would tell me this comes out to be roughly about the square root of 50. So here's A, here's B, and here's C. So in terms of proving if this is a right triangle or not, if in fact this is a right triangle, if I did a squared plus b squared, it should equal c squared. So if I did, I'm just going to sort of sneak this in on the bottom here, if I did the square root of 45 squared plus the square root of 5 squared equals the square root of 50 squared. And if you notice here, the squares and the square roots will all just cancel each other out. And what I'm left with here is 45 plus 5, which equals 50. So to answer this question, yes, this would in fact be a right triangle because when I go to do a squared plus b squared equals c squared here, this works out to be the square root of 50, which is the same thing there. So that basically takes care of some different things that we're going to look at initially here with plotting points and right triangles. Some of the other things that we're going to look at as we kind of move forward is some different things with the midpoint formula, and also some other formulas that are involved with graphing points.